In this video, we're going to look at communication technologies, and in particular, communication technologies that use radiation in the electromagnetic spectrum. We're going to start with telephony, then look at radio waves, the difference between an analog and digital signal. Then we're going to look at modems, firstly ADSL, and then optic fiber or cable modems. We'll then talk about television and finally how mobile phones work. A telephone is one of the simplest technologies that we use to transmit or communicate through. And what it does is it takes the sound wave that comes out of our mouths, goes into the speaker. The vibrating plate in the speaker then turns that sound wave into an electrical wave of differing voltage. That electrical wave travels down the phone line through the exchange to the telephone at the other end. The telephone at the other end then in the speaker takes this electrical wave, puts it back into a sound wave, and we hear that sound wave. So really it's just a system of a speaker and a microphone. Radio communications works in a similar way. The microphone at the radio station picks up the sound waves and turns that into an electrical wave. Then what happens is this electrical wave is modulated or added to a carrier wave and then transmitted. Then what can happen is radios that are tuned to that carrier wave, the particular frequency, then pick up that added wave. They remove the carrier wave, so we are just left with the original electrical wave. Then the speaker turns that electrical wave back into a sound wave, and we can hear what's going on. There are two different ways that radio waves can be modulated into a carrier wave. The first is amplitude modulation, or the AM band. And what this does is works by changing the amplitude or the size of a carrier wave. So the carrier wave has the same frequency, but the size or amplitude of it changes depending on the modulated wave or the original wave that's electrical wave. And these work in the medium wave length with a frequency of about 500 to 1500 kilohertz. The other type is frequency modulation. Frequency modulation is where the frequency is changed of the carrier wave rather than the amplitude. The amplitude stays the same. And frequency modulation occurs between 88 and 108 megahertz, or in the very high frequency section of radio waves. FM radio in the very high frequency relies on line of sight communications. So you need to be in a spot where there isn't any landforms or the curvature of the earth between you and the transmitting tower in order to be able to hear effectively. Shortwave, on the other hand, is reflected off the ionosphere. The ionosphere is a part of the atmosphere which is charged, and the waves get reflected off that ionosphere and then can bounce back down to the earth. So therefore shortwave radios can travel very long distances. And amplitude modulation, or AM, works in the medium wavelengths and can travel through landforms and has an extended range over the FM radio. So if we put this into a picture, we can see that the FM, or the very high frequency waves, need to have line of sight communications, while medium waves are able to travel through the earth, therefore can travel a bit further, and short waves, because of the way that they bounce off the ionosphere, can travel the furthest. There's two types of signals that can be sent when transmitting communication. You can send that signal in an analog form. So for example, telephones and radio waves that we've already looked at use differing strengths of a wave or transmit that in an analog way. Digital communications, rather than a differing strength, sends a series of pulses, so an on or off, And what this allows for is multiplexing, where multiple messages are sent at the one time. ADSL modems send a digital signal, so they're working digitally, down the analog copper wires. So what this means is that it's a series of ons and offs, or ones and zeros, that get sent down that line from the modem down the line to the server. So at your house, you actually need to use a splitter to remove the analog signal, so the one that you make phone calls on, from the digital one, which is the one that the modem is connected to. In some places, optic fibres are installed and you're able to use an optic fibre modem or a cable modem. This optic fibre replaces copper wires with wires containing many small optic fibres, which are each a glass tube that allows for total internal reflection of a laser light that's shone from one end to the other. Now, because light travels so quickly and it's so easy to tell whether there's light or not light, we can send a far larger amount of information down these optic fibers. So in your modem, there will be a laser. The reason a laser is used so that light of only one frequency is being transmitted. That light will bounce backwards and forwards inside that optic fiber. So it's reflected internally, and at the other end, so where the server is, that light will then be picked up by a sensor and turned back into the digital signal that your computer sent. Television can be transmitted as either an analog or a digital signal and is transmitted in the ultra high frequency and very high frequency range of radio waves. In Australia at the moment, we only use digital transmission of television. What this does is, because the digital transmission is pulses of on or off, it allows for more information to be transmitted, or more television channels, as well as the quality not to undergo degradation as much as an analog signal does. So with a digital signal, as long as you can make out the pulses on or off, you'll be able to get a picture. Where with an analog signal, the original signal, which was a up and down or a change in voltage, gradually undergoes degradation. So you could get anywhere from static to full picture. Whilst with a digital television, you either get picture or you don't. It totally turns off. Mobile phones also use digital communication, and they transmit these using microwaves. Each phone sends microwaves by line of sight to the base station or the local transmission tower. The message then goes from that transmission tower or base station to another base station where the receiver of the phone call is, using either the cable or the optic fibre network that's available in the area. And then at the base station at the other end sends that message again through microwaves to the receiving mobile phone. In places where there isn't a hard wire between the two base stations, for example, in a lot of cases calling internationally, these transmissions can be sent using communication satellites. And again, this is using microwaves to communicate between the base station and the satellite. So you can see in this schematic, the mobile phone sends microwaves to the base station. That base station will either send that signal through the optic fibre or copper wire network, or through microwaves to the satellite and then back to the receiving base station. And then the receiving base station will send that signal off to the receiving mobile phone. In this video, we have looked at communication technologies that use the electromagnetic spectrum. We talked about the most basic, which is the telephone. We've talked about radio waves, which are transmitted in either the short wave, medium wave, or very high frequency ranges of the radio spectrum. We've looked at the difference between an analog and a digital signal. We've looked at modems, which send a digital signal through an analog medium, the copper wires. We've looked at the optic fibre, which sends that digital signal using light waves through glass fibres, which is faster as well as allowing more data to be carried at once. We've looked at television signal, which is a digital signal in Australia, sent in the ultra high frequency and very high frequency ranges of radio waves. And we've looked at mobile phones, which use microwaves to transmit with base stations and then use other means to transmit that message from the base station to the receiving base station, and then again using microwaves from the receiving base station to the receiving mobile phone.